properly obtain the mass of your sodium bicarbonate, or baking soda, at home, you will need something to measure volume with. We have done this before, so this really should not be something new to you. We'll be using water's density as a standard of measurement. It really doesn't matter what you use to measure volume with. The easiest device to use would be something that measures in milliliters. However, most of us probably don't have something like this in our kitchen at home in America. So any of these will suffice, as long as you look up the conversion factors between it and milliliters. Use dimensional analysis to determine how much water you should be placing in your cup to obtain exactly 5 grams of baking soda. Then add your baking soda until the masses equal out and you have obtained the proper amount of baking soda. It is important throughout these steps to make sure the water you are using is room temperature. Otherwise, its density will not be accurate. To carry out the reaction, first transfer the sodium bicarbonate over to a larger reaction cup. When the reaction takes place, a lot of bubbling will take place, and you do not want it to bubble over and lose your products. Our goal in the reaction is to use a slight excess than is necessary of acetic acid, so that we are sure to react with all of the sodium bicarbonate present and convert it all to sodium acetate. We also do not want a large excess of acetic acid left over. To do this, we will slowly add acetic acid while stirring and monitor the amount of bubbling. The bubbling indicates the formation of carbon dioxide, one of the products. At first, the bubbling is very aggressive. Then, it will slowly die down and taper off. We must be careful not to assume that no reaction is occurring though just because a lot of bubbling is not present. So, we will add and stir in portions until we see absolutely no bubbling. Then, we will add a small amount of extra vinegar and let it sit overnight to let the reaction complete. Now we must get the sodium acetate isolated from the other products and the extra vinegar that was added in order to get its mass, to verify the law of conservation of mass, and to see how good our technique was. If we look at the chemical reaction, we know the products are carbon dioxide gas, liquid water, and our desired product, sodium acetate. The carbon dioxide is mostly lost from bubbling away. Therefore, we have a solution of sodium acetate dissolved in water. We also must remember that we added a little extra acetic acid than was necessary, so there is a bit of that in there as well. So how do we get all that separate from just the sodium acetate? One common method is to leverage what we know about the physical properties of the substances. We can look up the boiling points of the substances present and see the following. We can see that water boils away at 100 degrees Celsius, and acetic acid boils away at 118 degrees Celsius. Any carbon dioxide that has not escaped will quickly leave once the water boils away as well. That will leave behind the sodium acetate, which boils at a much higher temperature of 881.4 degrees Celsius. We can easily achieve this by placing it in a standard oven. The best way to do this is by pouring the solution out into a baking sheet with a small lid to contain the solution. This will help the process go much faster. Then, we place it in the oven at 150 degrees Celsius for about an hour, and that should do it for us. We should remember that some of the substance being boiled away is acetic acid. And this is an acid. You should never boil this away on the stovetop because this makes it easy to inhale vaporized acid, which is not good.
It's boiling acid!
Also, do not use a microwave for the same reason. You don't want to contain the vapors in a small area. The oven will do this over a long period and dilute the vapors, and ovens have natural ventilation. If it gets stinky, turn on a ventilation fan or ceiling fan and open some windows. Once you take it out of the oven, you should see some nice crystals spread out all over the tray. You want to let the tray cool so you don't burn yourself, and then scrape the crystals free using something firm, like I am using here. Try to get as much of them out as you can without losing any, and get them into a cup to obtain the mass you produced. The first step is determining the actual yield by getting the mass of the sodium acetate produced. Use your home mass balance to do this. You should be good at this by now. The next step is to verify your theoretical yield using stoichiometry. You should have done this in the pre-lab. You want to make sure now that you did this correctly. This is the mass of sodium acetate that the chemical reaction in stoichiometry predicts you should have made based on the mass of sodium bicarbonate you started with. We will now do a calculation using both the actual yield and the theoretical yield, called the percent yield. The percent yield is a calculation that chemists use a lot to inform on how well a laboratory process was at producing products. The higher the percent yield, the better the process was at getting what the stoichiometry predicts. The lower the yield, the more loss of products to various variables such as an error, side reactions, or other variables that cannot be controlled. We calculate the percent yield by dividing the actual yield by the theoretical yield, and then multiplying this by 100. It is important to keep track of sig figs, as always, through this calculation. It is also important to remember that not getting a 100% yield doesn't mean you are a failure or that you necessarily did something wrong. Some experiments simply will never allow for good yields. There are reasons for this. We are simply not ready to talk about yet. However, for this lab, you should be able to get a pretty decent yield.